Today, we will explore two concepts, weight and mass. Many people mistakenly use these words as synonyms. As you will see, using these words interchangeably is a mistake. Let's begin by trying to define mass. In chemistry, matter is defined as anything that takes up space and has mass. When a chemist thinks about matter, they are really considering its mass and how much space it occupies, or how many particles are in the sample. Mass is defined as the amount of matter in a sample. When the chemist thinks about matter, they really want to talk about mass. In physics, mass is the measure of an object's inertia. When we talk about an object's mass, we really need to be thinking about inertia. The property of an object to resist changes in a state of motion is defined as inertia. When we talk about inertia, we are really thinking about an object's resistance to changes in its motion. Inertia is an object's ability to resist changes in its state of motion. So, the more massive an object is, the greater its ability to resist movement. A more massive object resists changes in its motion more than a less massive object. The more mass an object has, the better is its ability to resist changes in motion. An object at rest will attempt to remain at rest, while an object in motion will remain in that constant state of motion until acted upon by an outside force. Unless it is acted on by an outside force, an object will remain at rest, or if moving, it will maintain a constant state of motion. Mass is measured in kilograms. Since we know that mass is the measure of an object's inertia, or ability to resist changes in motion, let's consider an example of mass using two different objects. For example, a baseball and a bowling ball. The mass of a baseball is much less than the mass of a typical bowling ball. A ping pong ball has less mass than a baseball. The higher mass value of a bowling ball makes it much more difficult to toss sideways when compared to a baseball. It takes greater force to toss a bowling ball than to toss a baseball. The higher mass value of a bowling ball also gives it greater inertia, making the bowling ball much more challenging to catch than the baseball. Because a baseball has less mass than a bowling ball, a baseball is easier to control when someone throws one to you than if someone throws you a bowling ball. Now imagine that instead of tossing and catching an object, you are pulling and pushing objects with different mass. When you pull sideways instead of lifting, you are not acting against weight per se, but against another force called friction that is related to weight. Technically, you are not acting against weight itself when you pull sideways on an object. You are acting against friction instead of weight when you pull sideways on an object. When you pull sideways on an object, it seems like the force needed to move it is due to its weight, but it is really due to its friction. If you use wheels when you move an object, you are ideally reducing the friction. An object on wheels has less friction than an object without wheels, so it is easier to move, or it takes less force to move it. This means that when you pull an object on friction-free wheels, you are really just pulling mass. If you could put frictionless wheels on an object, you would have no friction resisting your pull and you would be pulling only the object's mass. An object with less mass should be easier to move than an object with greater mass. The more mass an object has, the more inertia it has, so it takes more force to move it. Pulling an object carrying greater mass will seem more difficult than pulling an object carrying less mass, since the object with more mass will be more resistant to change in motion. So, the object with greater mass has more inertia than the object with less mass. The more mass an object has, the more inertia the object has. So when more people get into a car, then the car has more mass, thus more inertia. Now that we've talked about inertia, let's talk about Galileo's famous experiment on inertia. Before Galileo's famous inertia experiment in the 1600s, people did not accept the notion that a moving object is compelled to maintain its state of motion. Inertia is an outside force. Without an outside force against an object's motion, its motion would not change. An object at rest would remain at rest, and an object in motion would remain in constant motion. In the time of ancient Greece, Aristotle and others thought that the natural state of motion for all objects is to remain at rest. Before Galileo, people of the ancient would have thought the natural state of motion of all objects was to rest, rather than maintain their constant state until an outside force was applied. Aristotle and the ancient Greeks thought that objects need a constant supply of force to maintain motion. The ancient Greeks did not know that only an outside force could change the motion of an object. In his experiment, Galileo showed that an object does not need a constant supply of force to maintain motion by showing that a ball will roll down one ramp and up another without a constant supply of force. No force would be needed for an object to maintain its constant state of motion if all outside forces, including friction, could be removed. When started from a certain height on one ramp, Galileo noticed that a ball will continue to roll until it reaches the same height on the next ramp. Although Galileo could not eliminate friction completely, he noted that a ball would roll to the same height on the second ramp as it was released from on the first ramp. When one ramp was made less steep and longer than another, a ball would continue to roll until it reached the same height as it was at on the ramp where it started. If he made the second ramp less steep than the first ramp, Galileo noted that the ball continued to roll until it reached the same height as where it started on the first ramp, even if it had to roll a lot further. If a ball is dropped from a ramp and the second ramp is taken away, the ball will continue to roll forever so long as no other forces cause a change in its motion. Only an outside force, like friction, can change the motion of a ball rolling off a ramp onto a flat surface. In closing, mass is the measure of an object's inertia and is measured in units of kilograms. Mass must be greater than or equal to 0. What would negative mass imply physically?